Hello everyone, this is Dr. Prashanth and welcome back to Biostatistics lecture series. In this video, I will discuss about the population, sample, standard error and confidence interval. To start with the population and sample, population is a theoretical concept used to describe an entire group of individuals in whom we are interested. As it is costly and labor intensive to study the entire population, we collect data on a sample of individuals from the population who we believe are the representative of that population. What does it mean? Having similar characteristics to the individuals in the population. So, a sample is a subset of a larger population that contains characteristics of that particular population. So, I have given the symbols for both population and sample estimate so that we can differentiate between those two. So, mean, standard deviation, proportion and rate for both population and the sample estimate. Just go through them. And now coming to standard error, we have already discussed about standard deviation, right? So standard error is a measure of the precision of a sample estimate. It provides a measure of how far from the true value in the population the sample estimate is likely to be. So all standard errors have the following interpretations. Let's look into them. A large standard error indicates that the estimate is imprecise. A small standard error indicates that the estimate is precise. The standard error is reduced so that we obtain a more precise estimate if the size of the sample size is increased. It is very important. If the sample size is increased, the standard error is reduced so that we obtain a more precise estimate. And if we know the population standard deviation S, then the standard error of the mean is given by a formula sigma divided by square root of n. But in a single study, if you want to calculate it, we use a formula S divided by square root of n. So let's understand this with some examples. Before that, let's see the properties of distribution of a sample means. Because we have been discussing about the sample estimate and sample means, right? Let's understand what exactly the term sample mean. The mean of all the sample means will be the same as the population mean. Okay. The standard deviation of all the sample means is known as the standard error of the mean or SCM. So now you understood what is that word standard error, right? Standard error is the standard deviation of all the sample means. Okay. Given a large enough sample size, the distribution of a sample means will be roughly normal regardless of the distribution of the variable. So a simple example, standard error of a mean birth weight of preterm infants. Okay. See, there was a study which reported the birth weights of 98 infants who were born prematurely, for which the sample size is 98. X is 1.31 kg, S is 0.42 kg, and you can calculate the standard error by using the formula S divided by square root of n. So what is S in this case? That is 0.42 divided by square root of n, that is 98. So you got 0.04 kg. What is it? Standard error. The standard error provides a measure of the precision of a sample estimate of the population mean birth weight. So similarly, the formula of standard error for proportion will be P multiplied by 1 minus P divided by N. So if the sample size is N and R individuals have a particular characteristic, then the proportion will be R divided by N. Okay. So example, out of 124 patients, 57 patients responded to acupuncture treatment. Okay. And it follows a binomial distribution. Calculate standard error of proportion. So let's break down the question. Let's write down what they have given us. The sample size is n, that is 124. Individuals with characteristics, that is, what is the characteristic feature in this? Responded to acupuncture treatment, right? That is 57. So how do you calculate the proportion? R divided by n, right? So in this case, R will be 57 divided by the total number of individuals, that is 124. So you got P as 0.46. Now substitute the value of P in the formula of standard error for proportion, that is P multiplied by 1 minus P divided by N. So square root of what is P? 0.46 multiplied by 1 minus 0.46 divided by 124, which is sample size, that is 0.04. Now similarly, the formula for standard error of rates will be square root of R by N. Example, number of organ donations calculated over a 2-year period as R equal to 1.82 per day. So this is the rate, okay, 1.82 per day. We assume the number of donations follow a Poisson distribution and the sample size is 731. Calculate standard error. So just substitute the values in the formula. Square root of R, what is R? 1.82 divided by N, that is 731. So the standard error of rates in this case is 0.05. And similarly, standard error of differences, that is SC of D, is used when two groups are compared instead of one. And now coming to the next important concept, that is confidence interval. Confidence interval is an interval around the estimated mean, which we can be confident that it contains the true population mean. So it extends on either side of the sample mean by a multiplier of the standard error. Usually 95% confidence interval is most commonly calculated. So it extends 1.96 standard error either side of the mean. So the formula for confidence interval is x bar plus or minus z multiplied by s divided by square root of n, or in the other way, x bar plus or minus z multiplied by standard error. So let's understand the terms in the formula. Ci, that is nothing but the confidence interval. X bar is nothing but the sample mean, whereas z is the confidence interval value, whereas s is the sample standard deviation. Okay, now be clear, sample standard deviation, whereas n is the sample size. So let's understand with a numerical example. In the question, mean height of 150 students is given as 169.6 centimeters. So that was mean. And the standard error SC of x bar is given as 0.72 centimeters. Calculate 95% confidence interval. So they are asking 95% in this question. So let's break down the question and write down the values. Mean, that is x bar, is 169.6. Okay. And what was the standard error? It is 0.72. And by using the formula of confidence interval, that is nothing but x bar plus or minus z multiplied by standard error of mean. So that is 169.6, which is mean, plus or minus, we use the z value as 1.96 because they are asking us to calculate 95% confidence interval. So the z value for 95% confidence interval is 1.96. So that is multiplied by standard error is 0.72. So now you can see the symbol, right? Plus or minus. So confidence interval is always a range. So we need to calculate the lower limit and the upper limit. So for lower limit, we use the minus symbol. That is 169.6 minus 1.96 multiplied by 0.72. That is 168.2. Similarly, for upper limit, 169.6 plus 1.96 into 0.72. So now you got two values. So how to interpret confidence interval? It is very important. Even when you go through any article, you come across this, right? So be cautious about it. So in this example, we can interpret this as, from a sample of 150 students, the estimated mean height is 169.6 with a 95% confidence interval ranging from lower limit, that is 168.2 to 171 centimeters, which is the upper limit. Thank you.